Our last two sections from Chapter 6 on exponential and logarithmic functions are on applications. 6.7 has to do with financial models. The compound interest formula theorem. The amount A, after 10 years, due to a principal P, invested at an annual interest rate R, compounded 9 times per year, is this formula. Okay, so for continuous compounding, the formula is we have that naturally occurring constant E that comes into play here in finance with continuously compounded money. So this is money in the future, comes from taking the present amount of money, your principal, P, times this expression, 1 plus R over N to the NT. So let's revisit what all of these letters stand for. A is our future amount. And this is in dollars, of course. Principal, or P, is our present amount. Also in dollars. The rate is the rate of interest. And we would change it, it's in given in a percent, but we will change it to a decimal for calculations. Number is the number of times compounding occurs per year. Number of times compounding occurs per year. So this is an integer because you're counting how many times something happens. And time is always in years. Okay, so notice that the continuous compounding doesn't have an N because it's continuous, so it's not something you count how many times. Now, what do we mean by compounding? That means how often do they stop, calculate how much interest has been earned, and add that into the total. Okay, so that's the new P. After, if it's N equals 12, that means every month, for example, if you have money in a savings account, every month they stop, calculate how much they owe you based on the percentage, but then they give you that money, right? So your next principal for the next month is more than what you started with in month 1. Now in month 2, you have the principal plus what you earned last month. And now they pay you again at the end of the second month when they're doing it monthly. Okay, so let's look at examples, see how this comes out. Suppose you want to invest $10,000, so that's how much you have now, that's P. At an annual rate of 4%, there's your R, to a decimal would be 0.04. Find the balance, the future amount in your account at the end of 10 years. Okay, so T is going to be 10, if your money is compounded yearly. So how many times per year are they compounding your money if it's done yearly? Well, once, right? So A, your amount in the future, is going to be your principal times 1 plus the interest rate, 0.04, divided by 1 times 1 raised to the 1 times 10. There's our formula. And when you multiply that out, you get $14,000. So in 10 years, your $10,000 will grow to $14,000 if you have it compounded yearly. So that means 10 times, right? So quarterly, how many times per year would they compound your money? Yes, 4 times. So we'll just replace the N with 4. So now they're stopping every 3 months to give you your interest. So your principal goes up a little quicker that way, right? And now At the end of 10 years, you'd have $14,802.44. Well, monthly, we said that would be 12 times a year. And when you evaluate that, you get $14,908.33. Daily, well, we'll just go with a regular 365-day year. So every day would be 365 times per year. And that comes out to $14,917.92. And continuously, of course, we wouldn't have an N at all. We have A equals P times E to the R, 0.04, times T, which is 10. And that's $14,918.25. So what we see is the more frequent the compounding, the faster you earn money, right? And the difference gets less and less as we get closer to from daily to continuously, but it does continue to increase.